Welcome to the Laboratory, a video series brought to you by Miracles Innovation Labs.
Hello everyone, this is Monica Chirkuri working as lead researcher for Data Cognitive Analytics for Miracle Software Systems. This video is about how we can analyze FTP server logs using open source tools like Apache Flume and MapReduce. In this video, I'm going to cover about what an FTP server is and what are logs, how are they generated, how we can analyze the logs, what are the role of Flume, HDFS and MapReduce in this, and I'm going to give a brief overview on the architecture that we're going to use for analyzing these logs, followed by a live demonstration. FTP is a wide-known and well-known server for file transfers between different computers or different operating systems, or maybe from online. It works on a client and server mechanisms which supports operations such as uploads, downloads, deleting or renaming a file from FTP server. So for each of these actions that we do, whether it's an upload or download, we will generate an event called a log, and that will be saved in a log file on the server side. So this log file will contain information such as host address, timestamp, user login information, resources that are used, etc. So each server has its own logging mechanisms. Like not only FTP server, we have other servers such as web server, HTTP server. They all have their own logging mechanisms and the feeds that they use to store the logs. We can derive a lot of information from these logs by doing analysis on them. With time, logs keep on generated and they keep on appending to the log file, which makes the log file very bigger. So if you want to understand the log file, we can't really understand it by taking a look at it, because the log file will be in a semi-structured format. So as that the file is very big, the time taken for analyzing the file will be very time consuming. So when will anyone take a look at log files? Means most programmers only access logs when they encounter an error, or companies just access them when their applications are down. So at that time, what they'll do is they'll go back to the log files, review them, if they find the problem, they rectify it, which results in application downtime or maybe cost and everything. So most of the organizations, it is best practice for them is to have data logging and logging analysis as part of their security regulations. So it increases security awareness and also its effective management of applications. Logs are generally stored in hard drives. So taking high-end machines to store these logs which are infrequently processed will result in more cost. So it is better to store those logs in HDFS, because the HDFS provides a cost-efficient solution to store the logs, and it will store the logs in a distributed fashion. So Flume helps us in streaming those logs from the FTP server to the HDFS in real time. So as soon as the log is generated on the FTP server side, that log will be streamed at that particular time into HDFS without any delay or without any data loss. So MapReduce helps us in processing the logs once they are in HDFS, because the logs are generally processed only at the end of the day or at the end of the hour or at the end of the month based on requirements. So MapReduce provides us batch processing, which is suitable for this solution. This is the architecture for analyzing the logs. So the FTP server will be on a machine and the log file will be on the FTP server side, and the Hadoop distributed file system will be on a different machine. And in order to send the log files from one machine to another machine, we need to have two Flume agents, one on each machine. So this Flume agent will have an Avro sync, and the other Flume agent will have an Avro source. So what Avro is, it's a data serialization framework which manages the transport of data from one point to another point over a network. So this Avro syncs from the source Flume agent will send these logs in the form of events, which the Avro source of this Flume agent will capture them. So this will be done through an RPC connection between them. So once the logs are streamed into Hadoop distributed file system, we will use MapReduce to process all these logs. And once we process those logs, the result will be stored back into HDFS. So the business users can take a look at that result and detect anomalies, or they can even make plans to avoid risk, or they can even know the customer preferences. Let's go to the demo and see how we can analyze these FTP server logs. My FTP server is present on a VM called Miracle KVM, and the machine where Hadoop is residing is in Miracle Inspiron 3542. So now I'm going to transfer the logs from Miracle KVM to Miracle Inspiron 3542 using these Flume agents. So before doing this, we have to make sure that the Hadoop is running in the background, then only the logs will be stored into Hadoop. And also we need to start the target Flume agent first, and then the source Flume agent, then the RPC connection will be established successfully between the Flume agents. So let us run the target Flume agent first. We can see the Avro source on the target Flume agent has been started. Let's run the source Flume agent. We can see the connection has been established and the logs have started streaming. So let's go and see how we can generate log files. So these are the logs which are present already in the FTP server side. So let's try and use FTP and generate logs. Has been successfully logged into FTP server. Let's list what are all the files and folders which are there. I'm going to go into this FTP files folder. So let's see what are all the files which are present in this folder. So let's try and download one file. This will download the file to my local system. See, transfer is complete. So let's check the logs whether they have been generated or not. See, previously we only have these ones, and now if you can see, the login information has been recorded, and also the file which we have downloaded. See, it's specifying download. So the OK here means it's been downloaded successfully. If the download has been failed, you can see here it will show it as failed. So the logs will be stored in this way in the FTP server. Let's check out the Hadoop distributed file system whether the logs are being stored in here or not. So these are all the logs which are already streamed into Hadoop. So this is the latest file which is generated just now. So if you can see here, this is the file which we have downloaded into our local file system now. So this way the logs will be transferred to Hadoop distributed file system at that point of time without delay. Let's process all these logs. We can have MapReduce jobs coded to process all these logs. Based on our requirement, we can generate as many jobs as we can. Let's see this one first. So this MapReduce job will take timestamp and the file name. So it will tell whether that file has been downloaded at that particular time or not. So if it's downloaded, whether it's downloaded successfully or not. If it's uploaded, whether it's uploaded successfully or not. We can know by this job. So let's try and run this one. We have to give the arguments. First thing, we have to give the time. So the arguments don't take time directly, so we have to give a dot slash before it. And then we have to give the name of the file. And then run the file. We can see the job has successfully run and the output is written to Hadoop. Let's go and check the output. See here, the output will be stored in path file. So the file which you have specified is not found. So if we give a file and the time, so if that file has not been downloaded at that time, it will give this way. The result will be this way. So let's see another one. So this MapReduce job will take the date, like in day, month, year format, and also the name of the file, and it will say whether how many times a file has been uploaded or downloaded. So let's run this one. We have to change the file name, the job application name. We have to select the driver code for this. The MapReduce job will have a driver code, reducer code, and also the mapper code. And then we need to give the arguments. We have to give the day, month, and year. And then the file name. Let's run this one. The job has been successfully executed and the result is written back to Hadoop. Let's check it. See, this file has been downloaded 4 times on the date that we have given. Let's see another program. Here I'm specifying the host IP address, so I'm just going to see whether this user has downloaded how many files or has downloaded how many files or uploaded how many files, like that. So we can directly run this. So the job has been successfully executed. We can see that that particular host which we mentioned has downloaded 33 files successfully and uploaded 19 files successfully. Unfortunately, 5 of his downloads has failed and 3 of his uploads has failed. So not only like this, we can have different MapReduce jobs which serve different purposes, and using all this analysis, we can see. We can know the customer preference, which files he's going for, or based on that we can have custom marketing and everything. Don't forget to check out our other videos from our laboratory playlist. Thank you.
Thank you for watching The Laboratory, a video series brought to you by Miracles Innovation Labs. For more on innovation, please visit miraclesoft.com/thelabs.